Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Quart University of Science and Technology. Today we will take lecture number 15 of the subject of object-oriented analysis and design, in which we are going to discuss association, aggregation, composition and generalization in Java. Dear students, in today's class we will discuss these relations with the help of UML example and also with the help of the Java practical code example. These are representing certain relations which can be used to relate one class with the another class. And these relations are helpful to achieve the code reusability. Also, these relations are helpful in achieving the code compactness and code complexity issue resolution. So that's why these relations are important to understand and also very much important to be implemented in your project. This is the discussion agenda. First we will explain associations and then we will explain the association in UML with the Java code example. Then we have the aggregation idea and then we will explain the aggregation in UML with the Java example. And also we have composition and generalization. So we will explain all these terms with the help of the UML examples and also with the help of the Java programming examples here. So that's why this topic is very much important, because this topic explains you the object-oriented full essence with the help of this lecture. Now, we have three different important relations which are related with each other because association, composition, and aggregations are the subsets of each other. So first we have the composition. The composition is the, in fact, top concepts in which we compose the data member and member function in a single entity. Then we have the aggregation, where composition is the sub part of the aggregation. Means that in aggregation we access the aggregate classes here. And at the end we have the association. Association implements composition and aggregations both. In the association we can access the data member and member function of any class through declaring the associated object of that particular class. Just we will call that particular class with the help of the objects. That means that with the help of the objects we can access the data member and member function of any class, but that class should be either public or that can be inherited as well. But when there is the inheritance or generalization, then there should be certain functions in the parent class which can be accessible in the child classes here. First is the association in Java. As its name indicates, here we will associate one class with another class. So association is a relation between two separate classes which is established through their objects. Means that when we access the data member and member function of one class through another class by declaring the objects, then through this methodology this relation is called the association. Association can be of the different types. It can be one-to-one association, that means that one class exactly accesses the another class, or one-to-many association, that means that one class accesses many classes, or many-to-one means that many classes can access only one class, and many-to-many means many classes access many classes. So in OOPS, that is in object-oriented programming language, we in fact use the association for reusability, to kill the complexity, and also to achieve code compactness. Here, the functionality and services of one class is accessed to the another class through objects declarings. Composition and aggregation are two forms of the association. We will explain composition and aggregation after the association here. This is the diagrammatical representation of the association. Here we use a certain UML notations. For example, we have a bank class and there are one or more employees in the bank. So here two separate classes will be required. One is the bank class and another will be employee class. And these are the instances of the employees. Here we have declared three different instances of the employees. And the bank class is associated with the three instances of the employees with the help of the straight lines, which is an association. So here bank can have many employees, so it is one to many association, means that one bank contains multiples and many employees, so this is called one to many association. And this is the bidirectional association, means that here we can access the bank while here we will access the employee class objects. So this is the example of the UML through the straight lines, which represents the association here. This is the example of the association in Java. Here in the example, we are taking the same previous UML examples of the bank and employee. First, we need to declare the bank class, then we will declare the employee class, and then we will declare an association class, another class, which will associate the bank with the employees. So first here is the bank class. First we have declared import java.io.styles. This is the in fact the library and it can be used here. Then we have public class bank. This is the bank class. By default it is public. If we specify public here, then it will become public, but we have not specified the public here. So by default it is the public. Then here is the private string name. Private string name represents a data types of the name and its data type is the string and it is the private variable. That means that it cannot be accessed outside of the class. Here is the constructor of the bank class, that is the bank is a constructor here, and constructor is a certain function which will be called when we declare the object of this bank class. In the constructor we are here passing the string name, which is a parameterized constructor. This dot name is equal to name, so it will takes the parameters of the string name of that will represents the bank. Here then we are declaring here the functions public string get bank name. It is a string function and its access specifier is the public, and it will return the name of the bank. So return this dot name will returns this names, which is a variable of string data types here. Now here we have another class called the employee class. It is also a public class. Here we have the same private string name. It is in fact the name of the employee and its data type is string and its access specifier is the private. Then we have employee string name. This dot name is equal to name. It will in fact parameterize the name strings variables and it is a constructor of the name class. So when the object will be declared, then this will takes the parameterized variables of the name of the employees. Then we have public string get employee name. It is a function which we have declared as the string types and it is a public function that will return the name of the employee. Return this dot name. So it will return the name of the employee. Up to here, you can see that this class is completed here and this class is also completed here. So in one file, you will declare these two classes, and in the same files, we require another class which will associate bank with the employee class. So here is the class association public stated void main string args. This is the void main function inside of the association class, and its data types is in fact void, and it's is a static function, and also it is a public function. Here we first declares the bank object. Bank is equal new bank. State banks is the employee, in fact the name of the bank, which is a parameterized constructor. Here then we declares the employee class object. Employee em is equal new employee Ahmed. It is the employee parameterized constructors where we have passed the Ahmed as a name of this employee. Now we are associating these two classes with each other, so then we will call the function of these two classes through their objects. Then system.out.println imp.get employee plus is the employee of bank.get employee. So here the employee in.getEmployee will call this function, and it will return the name of this employee. Here is the employee of is a string which is concatenated here, and bank.getEmployee name will returns the name of the bank here, which is the State Bank. Now by just calling these functions, we are accessing the objects here, and these two are associated with here with each other. Ahmed is the employee of the State Bank. So it will be the output that here the Ahmed will be printed is the employee of the name of the bank here will be printed here. This is the example of the association in Java. Another important relation in UML is called the aggregation in Java. Aggregation is the association which represents the has a relation. Has a means that this is a certain relation where we associate one class with another class here. Has a is a certain relation which in fact calls the collection. For example, we can say that car has a wheel. So basically car has four wheels. So that one particular wheel is the part of the car. So that's why car has a wheel represents the aggregation relation. As its name indicates, aggregation represents the collection. So here one class represents the collection, another class well represents the part of that particular collections. Now association is a unidirectional association. That is, aggregation is a unidirectional association. That means that one-way relation. That means that communication can be performed from one direction to another. So there, bidirectional communication cannot be performed here. For example, department can have students, but vice versa is not possible. That students can have departments. So we can say that department can have students. So it is not possible, and thus unidirectional is in nature of the aggregation. So aggregation is one directional association. In aggregations, we have the entries which serves individually. That means that one entity will not affect the another entity here. So one entity is not affecting the another entity. Both entities here survives. If one entity is deleted, or in fact when one entity completes its life cycles, then the another entity will remains in the context of the project. So here aggregation is very much stronger. This is the symbolic representation of the aggregation in UML. So, for example, here is the college class, and there are students and teacher classes. Now, college class contains teacher, so we can see that here that college has a teacher. Similarly, college has a student. Exactly like that, we already provided you the examples of the vehicle. That vehicle has a wheel. So there may be one or more wheels of the vehicles. Similarly, there may be one or more teachers of the college. Similarly, here may be one or multiple students here. Mostly there may be multiple students in the college. So this empty diamond symbols pointing towards the collection or towards the aggregate class here. So here we have multiple classes of the college here. Now this is the examples of the aggregation in Java. First we have the address class and also we have the students class. And here we will associate these two classes with each other by association. So here is how we can declare the association. So in the first we have the address class. Here we have declares different parameters in streets number, then string city, string state, and string country. Here is the constructor of the address class, address int streets, comma string c, comma string st, comma string that is country, CONT. We will, in fact, in the constructors, we will pass the parameters here. So here we have declared different parameters of the same data types of that variables which we have already declared inside of the address class, and then we will assign these variables in the constructor to the actually declared variables here by using this pointer variables. This dot streets num is equal to streets, this dot city is equal to c, and this dot state is equal to st, and this dot country is equal to country. So here the parameterized constructor is declared here. So when we will declare the object of this class, then we will pass these parameters inside of the constructors of the address class. Now here we have the class students class. In the student class, we declare int roll number and string student name. So here we have declared two different data types of variables, roll number and student's name with their respective data types, integer and strings. Now you can see that first we declare the object of the address class here. But we have just declared it, we have not instantiated it. So address, students address, this is the object that we have declared. Then we have the students class, which is in fact here the constructor of the students class. Student class int roll number, string name, address. Now two parameters, roll number and students names we have declared here. But the third parameter is the address here. So address is not actually declared here, but it will be accessed through this aggregate class or the collection. So address DDR, which is the representing the address objects here, address object. So similar like this constructor, we have associated the one variable to another variables which we have declared here. So by using this pointer variable, this dot roll number is equal to roll, this dot student name is equal to name. Here this is in fact represents the current class object, which is the students class, and student class dot student address is equal to address. But address is the objects here of the address class, which we have declared here. You can see that address, student address, but student address is equal to address. So that means the third parameter here is the object. Now there is the white main function. Every Java program requires the white mains from where the class execution is starting by the compiler. Now in the word main we have address, add new address, first parameter, second parameter, third parameter, and another parameters. This is the another parameters here, and after another parameters you will see that there we have another um, objects, which is student class obj. So here first we have declared the address class objects, address, add new address 55 Kohat, KPK and Pakistan. These are four different parameters which are passed to this address class, because here you can see that in this address class the constructor is taking four different parameters. So that's why in the void main function we also pass these four parameters of the same data types as that is declared as inside of the address class. Now students class, obj new students class, this is another class of the students, and it is also the constructor here. But in the constructor we have declared two parameters and one parameters of object class. So ed is the object of the address, that means 123 and KUST are two parameters. You can see here, first is the roll numbers integer and next one is string student's name. So here we have passed these parameters here. So and address ed is the object we have passed inside of the constructor of the students class. So by this way we have associated one class with the aggregate class, and the aggregate class here is another class. So then we are calling through the object obj different parameters, and first we have called obj.roll numbers. As you can see that roll number is in fact in the here in the students class parameter roll number. Now obj.roll number will access the roll number which is 123. Then we have obj.students name, it will access the name of the students or name of the university, that is KUST. And then we have student address.street number, then we will access the street number which is in fact in the address class which is 55. Then again we have student address.city, city will be accessed here which is cohort here. And then we have the state is KPK and country is PAK. So that means that all these information are accessed of the other class, but that is in fact accessing through the objects which is in fact called in the constructor of another class here. That is called aggregations, and this is the output of this aggregate class. The third important concepts in the UML is called composition. The compositions provides you the belongs to relations, and composition is more stronger types of the association than the aggregation. And in association, we in fact says that then the object is composed of another objects. That means one object is composing the another object inside that. But another object cannot exist without the owner object. That means that the owner object is very much important in the composition. So, for example, if we have human have a heart, but human is not existing without the heart. So, similarly, heart is not existing without the human. So here, human object contains the hearts, and hearts cannot exist without the human. That is the composition, and it is very strong form of the association. The composition provides you belongs to relation as compared to the aggregation which provides the has-a relation. So here one object is logically larger structures at which contains the other objects. So human contains the heart. So human is the larger objects as compared to the heart here. So here this is the part of the human class. That's why it is belongs to relation. So it is also called has a relation. Means it is, we often call it as a relation as opposed to as a relation. Means that we can say that human has a heart. So it is also called the has a relation, but it is opposite of the is a relation, which is called inheritance, which we will cover in the later slides. This is the diagrammatical symbolic representation of the composition in UML. So here this filled diamond symbols which containing the object and is the base of this lines and there is no arrow key here, so you can do no arrow symbol, but this is a filled diamond symbol. So we draw the arrow head sometimes two here. For example, at this point we sometimes draw the arrowhead, but it is not necessary. So it is the container and it is one of the member. For example, building has certain rooms. So building contains the rooms, so it is the container of class, while room is one entity of this particular building. That is called the composition in UML. Here we are providing you the example of composition with the help of the Java example. First we have the date class. Date class contains different sort of the variables and also the constructor of the date class. Inside of the constructor, we are going to print some statements that system.out.println constructor of the data class is declared, is called here. So here we are calling the constructor of the data class. In the constructor, we are going to call the parameterized constructor. So that's why we are here assigning the declares parameters inside of the constructor to the actual variables here. Then we have public strings, two strings, and return day, month, and year. This is a function which will return the day and month and year that is passed in the constructor. Another one is the employee class, which has three different variables: ID, name, and hire dates. In the constructor of the employee class, we have int num string and date hire, exactly like uh, the compositions aggregations. Here we are declaring the objects here. System.out.println constructor of the employee class is called here. So it is in fact the constructor of the employees where the parameterized constructor is calling here. Now we have another function display which will displays all these three parameters which are in fact provided in the constructor. So this will display all these three different parameters here. Now here another class we have declares composition which will make the relation of composition with the date and the employees. So first we have declared date. So here we have passed a date and here is the employee 1 and Danish comma D. So here we are passing the employee class here. In the employee class constructor we are passing the D object of the date class. In the display will call the display function here. So when you will compile this code, you will get this output. Constructor of date class is called. First of all, the constructor of date class will be called. Then constructor of employee class is called here. And then this display function which are going to declare are printing three different parameters: ID, name, and hire date. So ID, name, and hire date is printed here. So it is representing the different collection, but when one site collection is deleted or that collection is in fact washed from the memory, then automatically the second dependent clause will also be uh, uh, affected here. It is called composition. And the last types of relation in the Java is called the generalization in Java, which is also called the inheritance, in which one class inherits the capabilities of another class here. So in the generalizations, the parent class provides the services to the child classes here. This process is also called converting subclass into superclass, called the generalization. Here is the example of the department, college, and university, and have a relation among them through the inheritance. This is just the inheritance symbol. This is the superclass, it is the subclass, it is also called the subclass, means it is also the leaf class here, it is the subclass. Okay. Here is another example of the generalization. First, we have the mobile class. Mobile class has the type Samsung, while the Samsung has the type Samsung Galaxy. So this is the superclass, also called the parent class. This is subclass, and this is sub-subclass. This is the example of mobiles having a subclasses Samsung, and Samsung Galaxy is shown here in the figure, which is a sub-subclass here. Here we are providing you the example of the generalization, also called inheritance in Java. First, here we have declared employee. In the employee class, there is a variable float salaries 40,000. So this is the variables of the 40,000 of the types float. Here we have the class programmers, which is extending from the implies. Here extends keywords means the generalization, also called the inheritance very commonly. So employee class is the parents and programmer is the child class. Employee is the base class in fact, and here programmer is the derived class here. Int bonus is equal to 1000. This is the variables we have declared inside of the programmer, which is the child class. Inside of the child, we are going to call the main functions, and in the main function, we have programmer p new programmer. It is a constructor of the child class. Through the child, we are accessing the data members of the parent as well as of the child. So the programmer salary is p dot salary, which will be accessed from the parent, and the bonus of the programmer is p dot bonus, which is in fact the variable declared inside of the inside in the child classes. So here two different variables are accessed. One is from the parent class and second one is of the child class. So this is called inheritance. If we are not inheriting, means that if we declare this a public private, so then the compiler will generate errors that you cannot access this variable which is outside of the scope of the programmer class. But because of the inheritance, we can access this variable here. So when you will compile the programs, you will get this output. Programmer salary is equal to 40,000 and bonus of the programmer is 10,000. So this is in fact the example of the inheritance where we are accessing the parent class capabilities, also the child class capabilities. Dear student, this is the end of the lectures. Here are two important references of the books. You can study these books for more concepts and also for this concept as well. First book is the UML Object Oriented Designs Foundations, and it is the Understandings of Objects Oriented Programming and Unified Modeling Languages, and it is the Professional Skills Editions, book 1 written by Kendall Editions. Okay, and also we have the Object Oriented and Programming and Java by Paul Demi Coing and Derek Ashok and Savarlata. So this is an important book written by the Springers and published in fact by the Springer. You should download these books and should study them so that you get complete ideas and also you get complete knowledge about the association, aggregation, composition and generalization in the Java. And still, if you have any question, you can ask this question through the email. My email is m.kadim@kust.edu.bk. Also, you can post your queries through the KCMS. I will answer your queries soon when you will post them. Thank you very much.